All right. We're just gonna get started. So last time we got a few things working. Deleting. So the next thing that we have to do is delete all obstacles when hit. Restart automatically higher up, and then hit splash particle animation. So I think the first thing I'm going to do is delete all obstacles when hit, and the second thing I'm going to do is the hit splash particle animation, because that's like logically that's the next thing that comes afterwards. And then I'll work on restarting automatically higher up. I think I have this one working, but I just have to test it out, and then we'll look into the camera shaking. So so I think when the hit occurs, it's further on down. 1-up hit. That's what it was called. 1-up hit. We got 1-up hit over here. Okay, so if 1-up hit is 1 and the hit token is over 100, then 1-up hit is less than 20. 1-up weight is less than if 1-up. Alright, yeah, so then this is where we have to pause and have this particle animation thing. And then the negative altitude equals negative altitude minus 5. Okay, and then we have to delete all of the we have to delete all of these things. Hang on one sec. Hi. All right, I'm back. All right, so here's where the 1-up weight is less than 20, and the negative altitude is minus 5. 1-up hit is equal to 0, and then the hit token is 0. Okay, so right over here we have to delete all of the. All right, so this means that you actually got hit, and we should probably clear the screen out. So that's probably going to happen over here. We probably want to clear the screen no matter what we did. So all girders and all drones, we probably want to do this. So hi, welcome. So I think that's the g.draw function. Let's see if we could add a remove function in there. Girder. Add new girder. Okay, so then there's the add function. Oh, add, and inside of add we've got draw, update, and what about just delete? So we have the delete thing in here. Let's see if we could just add a remove function in here. Function self, and then del self. Right? Is that how it's supposed to work? Yeah, del girders self. There it is. Girders self. And that's probably it. All right, and then we need the add new drone. Drones, and then del girders. We forgot the comma over here, so there we go. All right, so now that we got that, now we just got to go all the way to the bottom again, and then in here, remove, and then call the remove function in there also. Girders and drones. Okay, so that should be it. So now that when we hit into something, it should remove it. Oh, because now we can't hit into them. So now we're in the other, in that other range over there. Alright, so now we just gotta check the drones as well. Wow, this is tricky. Over here. Okay. Probably have to stop those from coming after below a certain size. I think that code we haven't written yet. Okay. So probably have to add some type of blinking for the first, you know, however long that you're immune to further hits. Alright, now I think we're in the time where we got a break from these drones. And now we're gonna head into the girders anytime soon. Oh, it's only gonna remove that one specific one. It's no wait, it's gonna cycle through all of them. Yeah, it should cycle through all of them because we're doing drones.all in addition to the one that you hit into. So I think that one's pretty cool. Yep. Okay. Used up too much. And now we're gonna get a whole bunch of them piling up. But they all disappear, which is good. So as soon as we figure out this like minimum size issue, we should have it figured out then. So now I'm gonna head to this one. Yep, there we go. Okay. So we got to reset, delete all obstacles when hit. Done. Restart automatically higher up. Needs to be a little bit higher than current. Alright, and then, alright, particle animation. I think we're ready for it. Alright, so somewhere over here we draw. There's a drawlet. We just have to find it. Add new droplet. Add new girder. Draw. Active droplet is right there. Okay, initial. Let's see, there's a draw in here somewhere. Draw, there it is. Ah, that's add new droplet. I'm looking for one up. Yeah, it's somewhere in here. Okay, first raindrop, there it is. Okay, and then we want the draw function, which is not there. Draw circle. Okay, there it is. There's the draw circle. We got that. Circle fill. XY radius 1. XY. Radius 12. Oh, no, so that's the color that you wanted. Color number 1. And then circle. Unfilled circle. And then now we want to explode this thing. So we kind of have to like stop drawing it and then this is going to take more than a few animation frames. So in here, probably just have a new variable called 1up explode, right? Yeah, 1up hit explode. Okay, so now 1up explode, what's going to happen, I think, is down here, over here, we're gonna have to do a 1up explode. Okay, 1up explode is gonna have to equal 1. And then the function that's gonna draw the 1up explode, which is all the way up there, is gonna have to clear it. Right? Add new array and initial draw circle. Yeah, it's not that one. It's yeah, it's not draw circle. It's the other draw one, right? Right below it. Draw first raindrop. Here we go. Okay, so draw circle. So instead of drawing this, is this a draw? Yeah. Instead of drawing the circle, it's going to have to draw the explosion, and then we're not going to get to. We're not going to get the 1up draw until the, until the explosion is done. So where is the draw? Overlay state is 0, and draw first overlay. Okay, so it's not, yeah, overlay state is 1. One up draw, there it is, right there. Okay, so 1up draw is called every single time. So if we just put it in over here, and the weight is definitely going to be above 20. If 1up explode equals 0, then draw a circle. Else, draw. Draw 1up explode. Probably takes all the same parameters. Oh, but then we also need like to know where in the explosion this is occurring. So we have to have like a, progress through the explosion, like explode T, explode timestamp. It's similar to exhaust, so I'm going to put it right in there underneath exhaust. Explode equals 0. Okay. Okay, 1up draw, 1up explode. XY radius direction. Okay, that looks good. And then over here, I don't think we have to worry about this part at all. because it's just going to draw the one-up draw anyway, and then this explode is going to tell us, right? Because this update is going to say, okay, you're exploding now. And then when you hit this draw, you're going to jump back up over here, and if you're under the explosion, you're going to draw the explosion. So then I'm going to end right there, and then here. Okay, so now this is going to look similar to the splash that's going to happen at the end. Alright, so you got the one-up explode over here. And it's going to look similar to the circle. What is it called? Draw circle. Okay, and then what was it called with the draw circle? Draw one-up explode. There we go, and then we had a t value of like how this is going to go. So, so for the first t, it's going to be let's take a look at what a raindrop. What I'm thinking of is a bubble exploding, but it's not exactly like that. So slow-mo raindrop collision. There we go. Okay. Do they have any slower motion than that? That's just showing the frames. Actually need all of the sometimes they'll go like super slow. Nope. There we go. Surface tension droplets. Okay, see you later. Thanks for watching. It's where it almost kind of bounces. That's pretty cool. All right. Be right back in a sec. All right. Where were we? Oh yeah, draw one up, explode. Okay, so now the timestamp is going to, the t value is gonna hit it, and then let's see, when it was falling into the, when the raindrop was actually hitting the surface tension, it kind of dunked below, and then it came up, and it was less, and kind of bottomed out at the same time. But what I'm expecting from the when it hits the surface is there's a splash. So it kind of has to all separate into like smaller components, I'm thinking. And then each of the smaller components have to get smaller and smaller. But I'm not exactly sure how to draw that without having to make a whole bunch of objects and everything. Let's try to first turn it all blue, for example. Circle fill with color number 12. And then we have to do this a certain number of times. T plus equals 1, and then if we do this like 20 times, t, if t is greater than 20, then 1 up explode is equal to 0 then. Just 0, and then we should probably return t at the end of here. Return t. And then over here, draw one up explode. Over here is up here. And then over here, self.explode t equals that. So then we're updating the value of t every single time. That probably should work. So it should turn all blue for a certain number of frames. So let's see if this works. There it is. I just gotta collect enough of these. Ah, I see what's happening. The t value is getting shorter and shorter. So if t is greater than 20, then 1up if t is greater than 20, then 1up explode. T should probably be equal to 0, so we can restart again, I think. I'm not 100% sure on this one, so we'll take a look. There we go. Okay. Yeah, so that's it. So that's probably the duration of the animation. It's around a second of, because 30 frames a second. So it's around a second of explosion of particle effect that we're gonna have. Okay, so that's the first thing. The second thing is this particle in the center is probably gonna, you probably don't need this thing either, so we can just get rid of this code. If radius is greater than offset, so then the offset, we don't need the offset either because we're not using it. Alright, so that simplifies it a lot. Okay, now, the circle is getting filled up with this thing. And that's as the explosion is happening. So then we have to have particles centered around this x and y coordinate, but a whole bunch of them. So instead of a circle, we're going to have a whole bunch of p sets. Now we can actually get into drawing this this p set thing. P set. All right, so now we need a whole bunch of them. We could do for loop 4. Let's see. We need like 60 of them or something like that. I equals 0, 60. Do p set. So we need an x plus I, y plus I, and the color is going to be 12. And then we need minus on this one. We need minus on this one. And then we need minus on both of them. But it's not going to be that. It's going to be like multiplied by 2. And that's probably going to be increasing every single time. Let's just see what this looks like. Circ fill. No, it's not down its end. Okay. Whoa. Lasers. Alright, so that's not what we wanted. We want them all around the place, all over the place, in a, you know, circular fashion. So there's a certain radius value, and then, you know, so we want a circle to be filled. Well, we don't necessarily want the circle to be filled. We want it in a circular fashion, and they're going to be increasing. So, actually, we don't necessarily need a for loop over there. We need to draw some of them in a circle. Do they have a thing like a dotted circle maybe? So let's check that out. Pico-8, Pico-8 circle. Okay. Draw state is used. Let's see. What we almost need to do is like rotate it and shift. Like have two of them and then have them like rotate and shift around the center. It's almost what we need. So let's see if we can do something like that over here with these. So we're going to do a pixel at a certain value, an x coordinate, a y coordinate, and an I. But we could use this formula over here for its value of a circle. 1 equals x plus y. X plus y. I think that's the, or maybe it's x squared plus y squared. Squared plus y squared. It might be that. Yeah, it's definitely that. 1 equals x squared plus y squared. Equals x plus y squared. Yeah. Yep. X squared plus y squared equals 1, and that's the value of a circle at 1. So we have to figure out how to do exponents in pico-8 exponents. Pico-8 exponents. Actually, a squared, we just have to multiply it by itself, so we don't actually need an exponent yet. So if we do x times x, that's going to be a huge value. But we could try it. X times x. Let's get rid of this for a second. X times x, and y times y. And I think we need the rest of the stuff, so we need a negative of x times x. And y times y, we need the positive of that. And then we need the positive and then we need the negative of this one, y times y. And then we need over here, we finally need negative of both of them. X times X, and then negative of Y times Y. All right, let's check that out now. And we're getting no pixels. So it's not centered around X and Y. We need it to be right there. So we're going to get a square around X and Y. What we really need is all the values around there. So let's see. Really needs the square root, I guess, right? Okay. Yeah. So we have to take the square root to figure out one of them, and then the square root for the other one, maybe? Yep, there it is. X squared plus y squared equals 1. So then you want to, if you know what those values both are, but you want to plot them around for every point around the circle over there. So sometimes it's going to equal 1, but other times it's going to equal a different value. All right. So if it's just X and Y, negative X squared, negative X is not going to give you something on the circle itself. So what we really need is we really need it to be divided by a couple of the numbers, you know, like subtracting out a few of the numbers. So let's do so we saw that the for loop didn't work because it was expanding out in all directions. Let's just try one of these. Just to make it super simple, and then we'll try this part later. So minus 1, and then minus them both. So this should give us a square of pixels around there in the right color that we're looking for. And then we can check it out next time. Yep. So that's what we wanted. But now we want it in a whole bunch of different directions with a whole bunch of dots everywhere. All right. So how do we do that? We could set it to a random value, but it's not going to have the same explosion effect. You want to set it from the center, and then you want to keep expanding based on the t value. So for every t value, you want to keep going up. So we can replace all the ones with t's. One comma, t comma. There you go. So now we just need more of these. We need them all around. So you got it in 2. So we need x, and then we need another 2 for 1. So you need, for every one of these, you need like +2, +3, +4, right? All right, let's see what this looks like. Yeah, something like that. So all around the center. Because you have an x and a y value, and that's a point. And then you have, for every time function, it's going one in a certain direction, but you can redirect it to a different direction by adding or subtracting a value. But if you do it in a for loop, you might bring the for loop back. 0.60 do. So we might be able to take, would we be able to take that out? I don't think so. What we'd have to do is we'd have to x plus t and y plus t. Right? I think so, that's what we'd have to do. Let's see, just give me one sec. Alright, now I'm back. Just had to look at something over there. Alright, so 0 to 60 do. It's in that location, so we would need an eye over there. We would definitely need an eye over here. So every single one, we would need a circle around it. We don't necessarily need 60 of them. We probably could get away with 20 of them. And what this is going to do is we probably want it to go all the way around the center, over there, like that. So probably want x plus t plus I. Yeah, x plus t plus I is at one position. And then you want to go to the second position. How do we do this? Okay, so x plus t is in the first position. I need like a graph paper almost. T. And then y plus t all the way out over there until 20. And then subtract a whole bunch. Let's see. Okay, so in this quadrant, we're going to have the pluses. Right, and in this quadrant, we're going to have the minuses, I guess, for the different quadrants. Plus, minus I. I don't know, I'll try that. I don't think that's gonna do what we want, because last time we just drew like a laser X. This time I feel like it's gonna be laser X also. Yeah. Yeah, so it's laser X going out. But we don't want laser X. We want it, you know, in a circle X. So we need something around the Y value, around the X and the Y value, but want something around the X and the Y value, but not going out laser-wise. We want it in the, around the circumference of the circle. We could do the radius squared, which we could determine by x and y, right? Oh, we have the radius already. So we could just run it through the circumference of a circle. Right. D equals 2 times the radius times pi. Alright, so we have the radius, and we have the x and y position, so we know where to place the pixel. We just have to do it along this radius. Diameter equals 2 pi times the radius, so we could get on it around the edge of that circle over there. Do we have a value of pi over here? We could always use 22/7 according to, I think, Barry Nicky from the last chat. Let's see, pico-8 pi. Yeah. Value. Yeah, I'm not seeing the math section of the API reference. Absolute value. Square root, that's awesome. So that's there if we need it. And that's it. Okay, let's see. Absolute value for mid. Yeah, I'd expect like just a little pi thing right over there. It's okay, we could always do 22/7. So we'll just do that one. Two times the radius times pi, which will give us the diameter. And then we need the circumference. So it's not going to be, circumference is not going to be, no wait, that's the circumference equals the diameter times pi, right? Yeah. A circle, there we go. Yeah, 2 pi r is the circumference, okay. So somewhere along there, depending on what the radius is, and that's going to give us the value of the circumference. So then we just have to add or subtract the circumference value from this. Right? Well, you're going to position that at a certain location. But then what is your x and your y value? Oh, I see. You can add and subtract the radius. For every point, you can add the radius. but it's not going to be exact. Right? Alright, so this shoots out a laser in every single quadrant. We don't want to do that. We want to have lots of these. I think I got it. Alright, so this has to go from negative 20 to 20. And then that's the X. Now we're going to shoot in this direction. We want to fan out. So if we want to fan out, we have to add X over here. But not add it to Y. So we almost need a for loop inside of a for loop. Let's see. For J equals 22. Alright, let's just see what this looks like. I have no idea what this is going to do, but I have a feeling we're going to have to do something weird like this. Okay, so that's still linear though. And it's just going out extra in one direction, which is that way, which is positive quadrant. So we really are not changing at all off of this linear thing. The only way to do it would be to alternate as to which side that you're adding it to. So like sometimes you would add to I, sometimes you would add to J. Let's see, maybe we can... Yeah, if we just add I and J, you get a line every single time that you'd want to go there. This is going to add in a line too. It's just going to be extra in the positive quadrant with this one, probably. Change over there. So this one, offset. Offset of the floor of radius divided by 2. Let's see, how do we do this? We draw a line. X offset, Y offset. I see. So there was an offset of radius over 2. So if we do something like that, we could subtract it from the X and the Y value, it looks like. Trying to picture in my head this thing exploding, but there's no, we're going off in this X direction because we're just doing X plus T and Y, X plus is I and J, which draws out every single thing in a line like that, but we need a whole bunch of P sets to be happening, but not on a line. So you would need it from X only. So you wanted like this line right here. You need it like you need to multiply one of these by 2. X value would be multiplied by 2 maybe? Probably not 2, it's probably like some, like 1.2 or something like that. I see. So it's going all the way over there. Yeah, I mean that's the thing. It's doing exactly what we tell it, but not what we're expecting. So if you wanted it, you want it based around the X value, but it's got to be a little bit different. So it's probably not this then. Let's see. You do want to do that for J equals 0,10 to done. And then you want to add J to this. I'm not sure what this is going to do. Not sure. We'll try out this one. Looks kind of interesting. Not exactly what I wanted. It is increasing everywhere, but it's kind of painting an image. So we want to draw around the circumference of this thing. You get the radius and you have the circumference. But how do we equate the two of them? I don't know, subtracting 1 and taking the square root of it? I'm not exactly sure. Let's see. Well, you could x comma y. No, that wasn't gonna work. You want to run this p set, but you want to run it in a circle. X plus y. And then, you know, just different values around there. Let's see, c equals 2 times radius times 22/7. Let's just try this. And then we don't have a... I'm not going to do this a whole bunch of times. So we can get rid of the j, and we can get rid of the I. Alright, let's just try adding c. Or subtracting c, depending on where we are. Do that, minus c, and this one plus minus c. Okay, try this out. Probably gonna look like a square again. I probably want to do the radius then, on second thought. Yeah. Gotta fix that up. Animation. Getting similar to what we want. Okay. So that's getting close. We probably want, instead of doing circumference, we would probably want to replace C with R. Okay, so it's getting closer. We're getting at the radius. So now we need a little bit more stuff to happen. We need an x plus 2, an x plus 3, all along the x values. So if we did this by hand, maybe we could turn it into a for loop at some point later. All right, let's see this. Unless we need every single one of those has to be a for loop. So that's probably not it. Let's see. So 2 minus 3. So this will be like right in a line. Because everything is equal, it's probably going to be a diagonal. Yeah. So that's a diagonal. So the x. I see what we have to do. So the x has to be constant, and you can only increase it by the y value. So you gotta multiply it by a percentage of that. Just the y value. So you need a y value, but it doesn't necessarily have to change with everything. Okay, so the y value, and then you only have the y values changing. And then you only have the x's changing. Okay, and then we need minus. All right, see how this looks. Honestly, this reminds me of Defender, the way this like kind of I think it was like when the Defender ship transports somewhere. Okay, not exactly what I was going for. Because of this thing. It's shooting out in the two different directions. So I wonder if this needs a plus I. And this needs a plus I. It's probably like a, it's gonna have like the laser beam effect, I have a feeling. Yep, there it is. Okay, so it's going in every different direction, but then you have these things which act like laser beams going down in those two directions. Not what we want exactly. But if we undo it a couple of times, we got to something that we did want. Yeah, there we go. You got these. 3 in a row. And then with all the same y value. It's going to stay on the same line, but I wonder how the rest of it's going to look. See, okay, so we're getting there. But it's got to move faster and be more fluid-like. So, write these in the to-do. Alright, that's it for tonight. I'll let you know how it turns out later. Alright, bye. Oh wait, yeah, there we go. Bye.